We have this formula over here. So the force is the rate of change of momentum with respect to time. We measure the momentum in kilograms times meter per second, and the force is given in newtons. So we have an object. The momentum is a vector quantity, and F looks at the same direction as the vector of the momentum. How can we prove this formula? We take Newton's second law of motion. So the force is the product of the mass times the acceleration. But we know that the acceleration is the derivative of time with respect to time. By the properties of differential calculus, m is just a constant. Of course, we don't change the mass here. Mass does not change of the object. Is m. We can write it as d dt of m times the velocity. But we know that the momentum is the product of the mass times the velocity. So what we obtain is that F is the rate of change of the momentum with respect to time. So this is a generalization of Newton's second law of motion. Again, let's explain a little bit from scratch. We have that the force is the rate of change of the momentum with respect to time. So imagine that you have an object, it moves towards this direction, and this is its momentum, and this is the force looking at the same direction as the vector of the momentum. We take Newton's second law of motion, which is F equals the product of mass times acceleration. The acceleration is the derivative, the first derivative of the velocity with respect to time. From the properties of the derivative, you have a scalar, m, which remains constant, does not depend on time. So you can write the derivative of m times v. So m times v, this product is, by definition, the momentum. So we deduce that the force is the derivative of the momentum with respect to time. And this is a generalization of Newton's second law of motion. Of course, acceleration and velocity look at the same direction as the momentum and the force. Okay. I hope that you enjoyed this video, and until the next time, I hope you are doing great.